The last tool I wanted to show you is the Find Your Chart tool. This tool enables you to have quick access to DSS, Sloan, 2MAS, WISE, and even IRSA images and catalogs. So let's put in M101. The defaults are fine. For now, I'm going to turn off the catalog search. It comes back with images at multiple bands for this source. So there's DSS images, Sloan images, 2MAS, and WISE. You've got all these images loaded in. Let's make some 3-color images. Click on this icon here in the upper right, and it creates a 3-color image, one per row for each of these rows. So there's a DSS 3-color image, a Sloan 3-color image, a 2MAS 3-color image, and a WISE 3-color image. If you click to select it, see it's outlined in orange, and then go up here, you can change which bands are which color planes. By default, it does WISE 3 for red, WISE 2 for green, and WISE 1 for blue. Let's say we want WISE 4 for red. Load. And then it changes what it uses for the color planes. To save these data, click on Download. You can download the original FITS files, HTML files, PDF files, or PNG files. Let's search again. The next object I want to show you is an object that I found in the WISE catalog that I identified because I thought it was a point source and because I thought that it had colors consistent with being star formation in our galaxy. For this example, the default image size is a little bit too big. We're going to do 60 arcseconds. Search. It comes back with all the images it can find for this region. So for WISE, it sure looks like a point source in most of the bands, and you just have to trust me, it's got the right color. But look at it in 2MAS. Those of you who have calibrated 2MAS eyeballs can already tell that maybe something's a little fishy. You go and look in Sloan and DSS, and sure enough, it is not a point source. It is most likely a background galaxy. Let's go back and do that search again, but this time, let's turn on searching the corresponding catalog, and let's search within the image boundary. Search. Now it's got all the images on the top, and it's in the process of loading the catalogs on the bottom. It's also going to overlay the catalogs on the corresponding images. So here we have the Sloan catalog on the Sloan images. We have the 2MAS catalog on the 2MAS images, and there's only 2 sources there. We have the WISE catalog on the WISE images. Now, if we go back to the Sloan catalog, you note that there's an offset between the sources and the overlays that turns out to be really there in the Sloan data. It's a real coordinate problem. Trust me, I've spent a lot of time working with these data. So this is not Find Your Chart being weird. This is actually embedded in the Sloan data. The sources do line up exactly right for 2MAS and WISE. So we were postulating that this thing is probably a galaxy. Let's go look for it in Sloan. There's 2 ways we can do it. We can call the Sloan tab forward and click on that target, and it will highlight the target for us. And if we scroll over, we can see what its measurements are. Another way to do it is because this is a catalog with all the same interactive features as you've seen in the other tables here. We can ask it to sort the columns so that the brightest source is at the top. And sure enough, that source is that 17th magnitude object, and Sloan thinks it's a galaxy. So I've successfully found star formation, just not star formation here. One last search I'd like to show you is batch search. It really shows some of the powerful things you can do with this Find Your Chart tool. I'm not going to tell you why I think these sources are interesting, because they are the core of the science I'm presenting in my poster, and I don't want to abuse my position in front of you and tell you why they're interesting. You'll have to find me, ask me later, I'll show you my poster about why they're interesting. But I have about 200 sources here, and I'm going to put this back at the default 300 arcseconds. Medium display size is fine. I'm going to turn off Sloan because it turns out there's not very much Sloan data for these targets, and I'm going to leave the other ones turned on. I'm going to search the corresponding catalog. I'm going to leave the search radius at the default. I'm going to turn on one-to-one matching so that it gives me one line in the output catalog for each one of the lines in the input catalog, even if it doesn't find a match. And it's going to take the closest source that it finds to my input position within that 5 arcsecond radius. Let's go search. So it has over here the input list of targets, and then over here on the right-hand side, it's got all of the images, just like in the searches before, and it's steadily loading on the bottom the catalogs that we asked it to find. So the first several sources are relatively clean. You can scroll through all the images, and they sure seem to be pretty clean point sources. Let's go down to the next one, and again, pretty clean point source in the first several sources in this bin. This one has a friend, but it still is a well-separated source. Source number 4 is starting to get a little bit more interesting. So it's clearly a point source for Sloan, for 2 mass, and for the shorter WISE bands, but WISE 4 doesn't have any sources at all. Let's go see if the stuff in the catalog corresponds to what our eye is telling us. So we're on the 4th source. Go down here, make sure we've picked the WISE tab. The 4th source is right there. You scroll over, and sure enough, that's a limit at WISE 4. So the catalog's agreeing with what we see by eye. Good. The 5th source seems to be a point source for DSS, for 2 mass, and WISE 4, it does not seem to be there. And sure enough, let's go see here, source 5, you scroll over, and it too is a WISE limit. So what might not be clear is that we've done the one-to-one matching, and so it's got a row for every input catalog, but the interactivity is still there. It's still overlaid the sources. You just can't really tell. So if you click on it, it does highlight the source in the catalog. The next source in my list is Arcturus. Now this one, the reason I have this on the list, it is screamingly bright. So in that sense, it's not terribly helpful. But look, for 2 mass, yes, it's screamingly bright, but the target is pretty well centered on the position that I gave it. And those data were taken in 2000. But by 2010, look, the source is still blown out, but it's moved significantly in the 10 years. And Arcturus does indeed have high proper motion. So we asked it to do an automatic band merge, and look, for source number 6, it didn't find anything. There's a row there, but it doesn't have any matches because it couldn't find a match within the 5 arc seconds that we asked it to look. So this is one of the really powerful things about this tool, is you can explore it interactively and discover things like that. So the next source in the list, source number 7, it is clearly boomingly bright at DSS, as you would expect for an HD star. It is really bright at 2 mass, and it's really bright at WISE. But let's go look. Row number 7 has no counterparts. How mysterious. How can this be? How can it be that it can be that bright but not saturated and still not appear in the All-WISE catalog? Well, you can do a little bit of detective work from within the Finder Chart tool. Click on the Catalogs tab and go over. As before, it's pre-filled search to match the region we care about, but let's change it to a cone, and let's look, say, over 10 arc seconds. We don't want 2 mass, we want WISE, All-WISE, and the reject table. Search. Now, let's see if those sources are actually there. Click on the image to select it. See, it's outlined in orange. Go up to the Layers tab and turn on the overlay of the catalog that I just loaded. Sure enough, that source is right there from the reject catalog. And if you scroll over, you can get the measurements of the source that we care about, even if they weren't in the All-WISE catalog. The next source in this list is an IRSA source. So you know it must be boomingly bright in WISE. So let's scroll down. It seems to be offset from a source in the DSS, and in 2 mass, and in WISE, it's offset in the same direction. Sure enough, it is screamingly bright at 22 microns, and it's definitely offset. So if I were, say, going to the telescope to try to get a spectrum of the optical counterpart to this, this tool would be very useful to go and examine the optical images and identify that I want to take an optical spectrum of that thing and not, say, that one. The next source on the list is also an IRSA source. If we scroll down, and there's a cluster that's bright at WISE bands. So this was originally an IRSA source. Let's see if we can help better understand what IRSA was measuring. Within the Finder Chart tool, you can overlay a DS9 regions file. I happen to have a DS9 regions file here that represents the size, the nominal size of the IRSA beams. Remember, the blue circle is the original target position. The slightly larger green circle is the nominal IRSA 25 micron beam size, and the larger green circle is the nominal IRSA 100 micron beam size. So you can see IRSA might have had some confusion issues, but on the other hand, by 22 microns, it's pretty well dominated by that central source. So probably IRSA was really only seeing that central source and probably didn't suffer too much from contamination by these other sources. Of course, you can go back and check. Let's go back, searches. Let's turn off one-to-one match. Let's turn on IRSA and look and see if IRSA found anything else within 90 arc seconds. If we go and search, remember we were looking at source number 9. So let's load that and scroll down. It's taking a little while with the catalogs because it's doing all 200 sources. So there, it's come back with the catalog, and we're looking at source number 9. So 9 is there. Now, we turned off one-to-one source matching. So in this case, if it doesn't find a match, there is no row. See, the first row here is 6. So if it found multiple matches, it would have multiple rows. But for source number 9, it has only the one source. So IRS really did have only one source in this vicinity. So to download the data, you can hit the download button and save data from just the current target or all the targets in FITS, HTML, PDF, or PNG. You can have it sorted into directories, sorted by object. If you have a lot of targets, I recommend that, and ask it to prepare the download. To save the catalogs, all you have to do is click on the diskette icon and it will save it to disk. If you've turned on one-to-one matching, after you save the catalogs, band merging across the catalogs is really easy because there's one line and only one line for each one of the input sources.